Hi everyone, this is a Math 082 video 3.5 multiplying polynomials. So this first example, they're not really polynomials, they're actually monomials. Okay? And if you look through and look at what we have, everything is multiplication. What we mean here is 4 times x cubed times y to the fourth times z times 2 times x squared times y to the sixth times z cubed. That's what we're trying to communicate by having that expression there. So the important thing to remember about multiplication is that order does not matter. And you guys know this. When you had to learn your times tables, you probably memorized that 2 times 3 was 6, but then you already knew, right, that 3 times 2 was also 6, which is nice because it kind of actually ends up cutting your multiplication facts in half. So what we can do, because of this commutative property and our ability to rearrange things, is that we can move numbers around so that they're next to other numbers or, variables with which they can be somehow combined. All right, so then I have x cubed, and then you might notice I have another x over here, which is x squared. So I'm going to put the x's next to each other since they have the same base. All right, let's find another color here. Okay, now I'm going to look at my y values. So I have y to the fourth and y to the sixth power, and I'm going to put them right next to each other. And then, this is turning into a very pink and purple and blue and red colors. Okay, and then we have z times z cubed. All right, so let's see if we can simplify this a little bit more. So 4 times 2 is 8. Okay, here we have x cubed times x squared. So this is the job for the product rule. If you remember way back to 3.1, we learned that the product rule teaches us that when we multiply terms that have the same base, then we can add their exponents. So this gives us x to the fifth power. Okay, then we have y to the 4 plus 6, or 10th power. And then z, remember we can always write a 1 here, right? 1 plus 3 is 4. So we'll write this in a monochrome sort of way so that it looks a little bit more professional. So we have 8x to the 5th, y to the 10th, z to the 4th, and that's our final answer. So the product of two monomials is itself a monomial. Let's do another example. In this example, we have a monomial, a single term, multiplied by a trinomial because we have 1, 2, 3 terms in here. So you've probably seen something like this before, and you may remember that what you need to do is distribute this term and multiply each term in the trinomial by the monomial. So let's write this out before we do any math. So we're going to have 4x cubed times 5x squared plus 4x cubed times negative 2x. If you wanted to, you could put the negative outside. It really doesn't matter where you put it, as long as you don't forget it entirely. Plus 4x cubed times 5. Okay, so let's keep going and see if we can simplify this. Again, I highly recommend rearranging your furniture. Move the numbers around so that they are adjacent to those terms with which they can be combined. Okay, so I have x cubed times x squared. Again, notice I'm not doing any math yet. I haven't done any mathematics at all. All I'm doing is moving things around. Okay, 4 times negative 2 is negative 8. Oh, I just did some math. Oh no, I cheated. That's okay, we'll leave it that way. Okay, and then we have x cubed times x. Sorry, I guess I just got ahead of myself there. Okay, and then we have a 4 here and a 5 here. So we have 4 times 5. Looks like Christmas here. x cubed. There's no other x there, as far as I can see. All right, so let's start simplifying some of these things, okay? So 4 times 5 is 20. Again, here we're using the product rule, right? 3 plus 2 is 5, minus 8x to the 4th plus 20x cubed. Okay, and that should be your final answer. All right, let's do another one. I think this next one is going to be even more challenging. Okay, so here we have two terms, which we call a binomial. So this guy right here is a binomial, and this one is another binomial. So you may recall FOIL. FOIL stands for first, outer, inner, last. Okay, so I'll write that out for you. First, outer, inner, last. That's what it stands for. Okay, you don't have to do it in that order. I, honest to God, almost never do. I never remember the order. I always want to do FIOL or something like that. All right, so let me tell you what I'm talking about so you're not totally lost and confused. So the first means the first terms in each binomial. So I have to multiply 4x times 3x. And again, that's the first terms. So let's write that out. We have 4x times 3x. Okay? Plus something. Let's use pink. Okay? Now I do the outer terms. The outer terms means the ones on the very outside. So this guy is on the outside, and this guy is on the outside. Remember, the sign goes with whatever the term is. So now I'm going to multiply 4x times negative 2y, because that negative sign goes with the 2y. All right, what's a good color here? Let's do green. Okay, now I just did the outer terms. Now I'm going to do the inner terms. So the inner terms are these two terms right here, 7y and 3x. So I have plus 7y times 3x. And then let's use blue here. Okay, last terms means exactly what it sounds like, the last terms, as opposed to the first terms in this expression. And it looks like we're running out of room. Oh no. So we're going to have plus 7y. I'm going to erase this. I can rewrite it. Okay, plus 7y times negative 2y. Okay. So let's go ahead and simplify this. Okay, remember, if you want to, if it helps you, you can rearrange these expressions so that the numbers are next to each other and the letters, or the variables, are next to each other. If this intermediate step helps you, then make sure that you do that. Okay, whatever helps you to get through the problem and make sense of it, then that's what you should do. So 4 times 3 is 12. X times x is x squared. 4 times negative 2 is 8. So we have minus 8xy plus 21xy minus 14y squared. Okay, so at this point we want to look for like terms. Are there any like terms that you see here? Remember, like terms are the same variable raised to the same power. I see two like terms. Do you guys see them? So the like terms are in the middle. So we have negative 8xy plus 21xy. That gives us 13xy. Remember, the rest of the equation is still there. It didn't go anywhere. And this is a positive 13 because 21 is the larger number and it's positive. So that should be, if we did everything right, that should be our final answer. All right, let's do one more problem. This is going to probably be the most difficult of them all. So this time we have a binomial. This guy has two terms, 1, 2. And this one is a trinomial because it has 1, 2, 3 terms. So as you can imagine, this is going to be a long process. I used to say when I taught high school, I would say, it's not that hard, it's just long. And then I would get a lot of snickers. So I don't say things that way anymore. I say, it's not that difficult, it just takes a long time. So here we go. All right, so we're going to just do this in order. So we're going to have 2x times 4x squared. Okay, let's see if we can make a cute little rainbow. Got to make some fun somehow, right? Okay, then we have 2x times negative 7x. Okay, and then let's use this yellow color here. Hopefully it's still visible. Okay, plus 2x times 3. Okay, so we got through our first set, our first 3. Now we're going to move on to our second 3. So we've already multiplied everything in our trinomial by 2x. Now we're going to multiply everything in our trinomial by 5. So I'm going to have minus 5 times 4x squared minus 5 times minus 7x, and then my favorite color in the world is purple. So we have to use purple because purple is part of the rainbow. Okay, so minus 5 times 3. Yay! Alright, I'm going to keep using colors because colors are awesome and they're fun and they make me happy. So we have 2 times 4 is 8. X times x squared is x cubed. 2 times negative 7 is negative 14. X squared. Remember when you're watching these videos, you know, you can speed them up, you can slow them down, you can pause them. You have lots of options. So if I go too fast, you can play them at a slower speed, or you can pause them. If I'm going too slow, you know, you can skip through or you play them at a faster speed. All right, so we have minus 5 times 4, so that's negative 20 x squared. This blue guy, remember there's a negative and a negative. Negative times a negative is a positive. 35x plus 15. Okay, if you recall, I'm going to go back quickly to our previous problem. At this stage, we looked for like terms. Remember that? So we need to do the same thing here. We need to find, and there might not be, sometimes there are not like terms. It totally depends on what you started with. Okay, so let's see if we can find like terms at this stage. And as you can see, I've already used all the colors of the rainbow, so I'm going to have to use some different notation. So what I'm going to do is I'm going to use boxes, and this works well also if you're using like a pen or pencil, you know, just monochromatic. Okay, so negative 14x squared, do you guys see? I see this is a like term. Okay, so then how about 6x? I will use a circle here to circle 6x and 35x. They are like terms. So let's see if we can finish this up. Okay, so we have a negative 14x squared and a negative 20x squared. I'll do this extra step. Again, you so totally don't have to. It's really up to you. But if it helps you to first rewrite this, like rearrange things before you combine like terms, then you can do that. It may very well prevent you from making needless, that's a 3, damn it, needless sign errors. So, yeah. All right, minus 34 x squared plus 41x plus 15. Okay, so if we did all of our math right, all of our arithmetic, that should be our final answer. And again, all of our x's, all of our variables have different exponents, so at this point, there's nothing else that we can combine.